Now let's go through a couple other properties about the trigonometric functions. And the first thing I just want to touch on briefly would be the domain and range of the sine and cosine functions. So in both cases, the domain is from negative infinity to infinity. And I want you to think again about that function, right? So it's sine of t equals y and cosine of t equals x. Now remember, t is the angle. And we've said that the angle can be any real number. Now, well, you may be saying to yourself, yeah, but isn't the angle really between 0 and 2 pi or 0 and 360 degrees? Yes, but don't forget we have coterminal angles, right? So you could actually perform more than one revolution, or you could go backwards and have a negative angle. Those would all be fine. So actually the domain is all real numbers because the angle really could be anything. It doesn't have to stay between 0 and 2 pi or 0 and 360. It could be another coterminal angle. So in both cases, the domain is between negative infinity and infinity. And also in both cases, it has the same range. And the range is between -1 and 1. And that's because if you look at the output, right? So the domain is your input, the range is your output. So if I look at my output, the answer is always either X or Y. Now remember that we're dealing with the unit circle here. So the radius is only 1. So for the X values, if you look at your circle, the highest X value would be 1 and the lowest X value would be -1. So for your domain for cosine is between 1 and -1. And then for your Y values, again, your highest Y value is 1 and your lowest is -1. So for the sine output, again, you're going between -1 and 1. So both sine and cosine have the same domain and range. Both have the domain of negative infinity to infinity, and both have the range -1 to 1. Okay. Another kind of little detail I want to talk about here. So this video is going to contain kind of a couple just little things that you need to know. And one of them is working with the angle of pi over 4. Now, for other angles, when they end on one of the axes, you can find the point very easily on the unit circle, right? 1, 0, 0, 1, -1, 0, and 0, -1. But when the angle lies in the middle, it's a little bit harder to find that point. And pi over 4 is a very common angle that we deal with a lot. So there's a few common angles. Pi over 4 is 45 degrees. 30 and 60 degrees are also pretty common, but 45 degrees is probably the most common out of the angles that do not lie perfectly on an axis. So this one's a little bit harder to work with. So let's figure out how this one works. And I'm going to start by drawing a picture because, again, it's all the unit circle. Right, so this is still the 0.1, 0. And you want to think about pi over 4. Pi over 4, if you go back and think about the picture that we talked about, is one of our main pictures that we did. It's that 1/8 turn. So it's, 90 degrees is the full vertical line, but it's half of that. So it looks, it kind of cuts right here. So this is your pi over 4. Now, also remember that your arc length is the same on the unit circle as the angle, right? Because the radius is only 1. So the angle and the arc length there are both pi over 4. Now, this is a little bit tricky. You kind of have to think about this a little bit. But what happens is when you cut that perfectly in half like that, that ends up lying on the line y equals x, which maybe is not obvious. So when you have that 45-degree angle, you're actually on the line y equals x that you can graph. So when finding this point here, well, because y equals x are actually going to be the same value. So whatever that point is, let's just call it, you know, A, it's actually A comma A, not A comma B being different values, because specifically at 45 degrees, you're actually on the line y equals x. So y and x have the same value. Very special, very specific. So that's why we can kind of make this work. Now, your equation for your unit circle is x squared plus y squared equals 1. And I do know that, you know, my value is the same in either case, whatever it is, the x and y are the same, we'll call it a. So you end up with 2a squared equals 1. Dividing both sides by 2, we get a squared equals 1/2. And then taking the square root, we get a equals the square root of 1/2. Now, I know when we take the square root, we take the positive and negative, but if you look at my picture here, 45 degrees is clearly in the first quadrant. So I'm looking for the positive values for a. I don't really like to have the root in this form. I'm going to clean it up a little bit. Square root of 1 over square root of 2 is 1 over root 2. And I'm going to rationalize that denominator. So root 2 over root 4, which is root 2 over 2. So we actually get that the point here is square root of 2 over 2, comma square root of 2 over 2. And now we're actually able to complete the rest of them. So, you know, sine of pi over 4, remember that's going to be your y value there, which is root 2 over 2. Cosine of pi over 4 is the x value, but that's also root 2 over 2. So you can, it's a little bit of a nice pattern there. And maybe we'll just do one more. We can just do tangent. You guys can figure out the others at home. So tangent of pi over 4 is going to be y over x. Let me give myself a little bit more room here. So root 2 over 2 over root 2 over 2. Now, if you can't see it yet, this value is actually just going to be 1 because you have the same thing being divided on top and bottom. But if you're not sure, you can do a little bit of algebra. So we can flip that denominator and multiply it on top and bottom. That's how we cancel it out from the denominator. And then you end up with 2 root 2 over 2 root 2. And hopefully now you can see that everything's going to cancel and you're left with just 1. So tangent of pi over 4 is 1. And you can find the other values as well. You have a little bit of algebra to do there because you have some fractions and fractions, but you can clean them up just like we have with other examples. And to make it a little bit easier for you, I'll just give you the answers, but you can check them out at home. So cosecant of pi over 4 ends up being just the square root of 2. Secant of pi over 4 also is the square root of 2. When you clean these up, you get the same answer, very similar to how sine and cosine are the same. And then cotangent of pi over 4 is also 1. So you do have exact values for pi over 4 now that you can use as you're going through. But again, this was a really special case because it's not easy to find those points on the unit circle sometimes without extra information. Here we had to use the idea that pi over 4, because it's at 45-degree angle, would actually be on the line y equals x, which may not be obvious, but that's why we can find it. Now, the other thing I want to show you, and again, you have this in your text, but you can Google search for these images. They're very, very popular. So this is an image of the unit circle. Let's see if I can get this on the screen here. And again, you don't have to copy this. You have it in your text, and you can also just do a Google search. Let me get it better on the screen here. There we go. But what they have done here is they've given you those key points for the other angles. So we knew 1, 0, 0, 1, -1, 0, and 0, -1. Those were easy. And we just together found the point for pi over 4. But again, there's other common angles. 30 degrees and 60 degrees are very common as well. So what this little chart gives you is it gives you those key points all the way around for your most common angles. So you don't have to be finding them on your own like we just did with pi over 4. So again, this is a really good reference for you. This is one that you want to hold on to, kind of keep with you until you learn some of the points. You don't have to memorize them, but as you work with them, some will become more familiar. And again, if you're not using your text, if you Google, unit circle, trigonometry, angles and points, things like that, a lot of these images will come up for you very quickly. So you have that here. And then that will allow you to find the trig functions for any of those key points without having to worry about, well, what's my point on the unit circle? You have it. All right, so there's so many different tidbits about trigonometric functions in the unit circle that are helpful. So I'm going to give one more in this video, and then I'll pause and we'll break and go to another video so it doesn't get too long. So one thing I want to note is even and odd functions. And hopefully you remember about even and odd from your algebra class. So a function is even if when you plug in a negative for it, you get the same output. So whether it's, positive or negative, when you plug a value in, it doesn't matter. So a classic example of an even function is x squared. So just as an example, right, if I plug in 2, I get 2 squared, which is 4. Or if I plug in -2, I get -2 squared, which is still 4 because that negative cancels out when you square it. So this is something that's even. You'll see even functions are also symmetric with the y-axis if you're more of a visual person. So this function here, when you graph it, is like a U shape. So it has that symmetry with the y-axis. Something is odd if when you plug in a negative of it, you get the negative output out instead. And again, a classic example is x cubed. For instance, if I put in f of 2, 2 cubed is 8. And if I put in f of -2, -2 cubed is -8. So notice that the number is the same, but the output switched from positive to negative. So again, you have very similar outputs, but the sign changes. So if it was positive, it goes to negative, or if it was negative, it goes to positive. And for symmetry, you actually have, this is symmetric with the origin. So you kind of have this diagonal symmetry. It's almost like a double flip, or it's a 180-degree rotation around. So you do have symmetry, but it's more of a diagonal one in nature. So trigonometric functions can have even and odd properties as well. Excuse me, guys, I'm so sorry. So for our even functions, cosine and secant are actually even. So if you plug in a negative for cosine, it doesn't matter, you get the original back out. And the same thing for secant. If you plug in the negative version, you just get the original back out. It doesn't matter if you put parentheses around the t or not. Here you do want them because of the negative sign, but this is the same thing as writing this. It doesn't matter. Your odd functions would be your sine, your cosecant, your tangent, and your cotangent. So again, if you take a sine and you plug in, let's say, a negative angle instead, you get the negative of the output. Same thing with tangent. With cosecant, and then also with cotangent. So let me just do a couple examples there so you can see how this is helpful. It just kind of lets you take a little bit of a shortcut, because if you know the answer for the positive version of the angle, then you can find it really easy. You don't have to do a lot of extra work. So for instance, let's say I'm looking at cosine of -pi/4. So cosine is an even function. So if I plug in a negative, it actually doesn't matter. It's the same answer as if it was just cosine of pi/4. And we actually just did cosine of pi/4 a second ago. And we got it was root 2 over 2. Let's say I did tangent of negative pi over 4. Well, tangent is an odd function. So what happens is basically that negative sort of comes out. It's negative tangent of pi over 4. Now we did tangent of pi over 4 just a minute ago. It was 1. So this part is 1. And then that negative is going to tag along there, -1. So it's just really nice because you don't have to figure out, the negative rotations necessarily. You don't have to kind of draw the picture and figure out the negative rotation and where's that point. You can use the idea of even and odd and what you already know with the positive rotations to get your answers. So it's just another way to do it. And again, it can make your life a little bit easier.